Okay, let's carry on. There is a good reason. There's a good reason why we started off with limits. We're going to use the idea of limits to do this thing called differentiation from first principles. All right, differentiation from first principles. Bear with me. Let me try and sketch this thing for you. Okay, suppose I have a graph y equals to fx. All right, and I want to find the gradient at this point P. All right, P obviously has this coordinate x, fx. All right, and I let another point Q be some distance away, Q, okay, at about at delta x away from this. So actually it is a distance delta x away. Okay? And I think it's not difficult to say that the y coordinate is fx plus delta x. Okay? Where this one, if I may mark here, this is what I call delta x. Alright? Then this change here is what I call delta y. Now, the definition of gradient is this, because I think most of you will know how to draw gradient. The gradient at this point P is to draw a tangent here, if you see it, something like that. Alright? Yes? I'm sure you can. You'd appreciate that, and you have learned that before. Now, but the definition actually, so before that, actually the gradient of PQ is what? The gradient of PQ is delta y over delta x. Now, I'm not saying this is the gradient at point P, but it's not difficult to see that this is f x plus delta x minus f x divided by delta x. Now, the definition of the gradient at P here is actually the gradient of PQ, right, as Q tends closer and closer to this. That means as delta x tends to 0. So I'm going to give you a nicer looking diagram, and then I illustrate a little bit for you. So this is exactly the same thing I drew just now, all right? And if I define PQ, the gradient of the chord PQ, this line PQ, all right, this line from P to Q, it is actually this gradient, this value, right? Now, what happens if I make delta x as small as possible? This is what happened. Okay, maybe I show you. All right, let me orientate you. This is P, this is Q. Ignore the A and B. All right. As it comes closer and 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 closer, you realize that the gradient of this chord here, of the short line there, actually tends closer to the tangent. The dotted line actually is the real tangent. If you see closer and closer, 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 it becomes closer and closer to the tangent. So this is what is going on. So therefore, by definition, to find dy dx, I just let delta x be as small as possible, and this is hence the gradient of the tangent at that point P. Right? This dy dx here, this is what dy dx is at P, of course. Okay? Right. Shall we take a look at one example? This is actually, this derivation, these principles actually helps us explain a lot of our formula we learned in secondary school. Alright? It's not difficult. I mean, everybody knows the answer for the derivative of 2x. X squared is 2x. Now what we want to do is to use the first principles to help us explain why must it be 2x. Again, let's go back to this again. Alright? It is when you let delta x be as small as possible, all right, when you find the gradient of this chord PQ. Again, I go back to this like that, right? As you get closer and closer and closer to it. All right, so let's go to the question here. So what should we start off with? We start off with this thing, let fx be x squared, and then the gradient is essentially f x plus delta x minus fx divided by delta x, and we still want to find when delta x tends to 0. But actually what is fx in this case? I'm interested in x squared. So therefore, if f x plus delta x is actually x plus delta x squared, fx is obviously x squared. Then I expand this. A plus b whole thing squared is x squared plus 2ab plus b squared. I carry on by writing it here. My x and my x goes. Correct? Yes. And then I carry on from here. Alright? Delta x tends to 0. I factorize my delta x out. I'll get 2x plus delta x divided by delta x. And my delta x goes, I will get this limit delta x tends to 0, 2x plus delta x. Now then it is important for us to recap what we learned earlier, which is, does the left limit equals to the right limit? And in this case, yes, the left limit equals to right limit. When delta x tends to 0, this thing tends to 0, then you will get 2x. Now magically, of course, you will get the same answer. So that actually helps us explain, like I said, a lot of your secondary school formula. Now, it is actually useful to know that all this is backed up by first principles. It's not something that we pluck out from the sky. But there's no need to look for you to learn the proofs. But this is just for exposure and to know from this. All these are from first principles. Once you know that, then we will go on to the hard differentiation skills later on. Thank you.